The final part of Mod 3 deals with the unit circle and even and odd functions. First, we're going to look at unit circles. A unit circle is a circle in which the radius is 1. If we go back to how we defined our trig functions and use 1 for r, because now we are in a circle that has a radius of 1, then the sign becomes y over 1, which is just y. The cosine of theta becomes x over 1, which simplifies to be x. Tangent will not change because tangent does not have r in it as its definition. Tangent is still y over x. But now cosecant becomes 1 over y, secant becomes 1 over x, and then cotangent stays the same as x over y. We are going to use this figure to help us see what the labels for a unit circle should be. If you look at this figure, you will notice just in looking at the first 2 quadrants that if we look at how the lines are marked, just in the first 2 quadrants again, remember that each of these points has divided that now into 1, 2, 3, 4, 5, 6 equal sections. Remember that all the way over here is pi. So each of these sections is 1/6 of that. So the first line would be at pi over 6. The second line would be 2 pi over 6. The third line would be 3 pi over 6, but that equals pi over 2. The next line would be 4 pi over 6, and then we'd have 5 pi over 6, and then recognize that pi could be thought of as 6 pi over 6. If you go to the bottom 2 quadrants and continue that pattern, we would have 7 pi over 6, 8 pi over 6, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, 11 pi over 6, and then 12 pi over 6 is 2 pi. This is also 0, don't forget that. And then if we think about this in terms of degrees, pi over 6 is 30 degrees. 2 pi over 6 will be 60 degrees. And if you think about that, we have taken 180 degrees and divided it into 6 equal pieces. So it makes sense that each of these would represent 30 degrees. Pi over 2 is 90 degrees. Then we have 120 degrees, 150 degrees, 180, 210, 240, 270, 300, 330, and 360. Now that we know how each of those lines would be labeled, I want to go back to this figure again and just look at this first triangle that we could create. So if we were using this first line, which up above we just talked about was 30 degrees, what that means is that this angle is 30 degrees. And if I drop a perpendicular, well, now I have a 30, 60, 90 triangle. This goes back to something we've already learned. We know that every 30, 60, 90 has the relationship of 1 to square root of 3. We said, now that we are in a unit circle, that our cosine is just plain x. So if we go back to a 30, 60, 90 and do the cosine of 30 degrees, we said that cosine, remember, was the ka. So cosine of 30 equals adjacent, the side connected, square root of 3 over the hypotenuse, which is 2. So that means that in our unit circle, the x-coordinate will be the square root of 3 over 2 because it is the cosine. The y-coordinate is the sine for 30 degrees. So come back down to our 30, 60, 90 triangle and remember that sine was SOH. So sine of 30 equals the side across from the 30 degrees, which is the 1, over the hypotenuse, which is 2. So the y-coordinate is 1/2. And this is all because this is a unit circle and the radius is 1. We are going to ignore the 60s for right now. If we go over into quadrant 2, we have a reference angle of 30 degrees again. So we could create another 30, 60, 90 triangle over here. So what that means then is that the cosine is the x-coordinate, and we said that cosine for 30 degrees was the square root of 3 over 2. The sine is the y-coordinate, and we said the sine is 1/2. But remember, when you are in the second quadrant, your x-coordinate must be negative. So the cosine is negative square root of 3 over 2. If we go down into the third quadrant, we have another 30-degree reference angle right here. So we have another 30, 60, 90. The order of our coordinates is going to stay the same, but when you are in the third quadrant, both of them must be negative. So the x-coordinate is the cosine of 30, negative square root of 3 over 2. The y-coordinate is the sine of 30, which is in third quadrant, negative 1/2. If you go to the fourth quadrant, we have another reference angle of 30 here. So we have another 30, 60, 90. So the coordinates will be the same order, square root of 3 over 2 and 1/2. But recognize that in quadrant 4, the y value must be negative. Now, the other thing I want you to notice about this is that if we folded this circle on the y-axis, this dot would line up with this dot because of symmetry. This dot would line up with this dot. So that's another way to help you remember what the coordinates are. They are going to be the same. You just have to be careful to pay attention to signs based on what quadrant the point is in. We're going to use this same figure one more time. But in this case, we are going to look at the lines that are closest to the y-axis in each quadrant. Because what happens is that your reference angle is 60 degrees. So now, if you draw a triangle, you've got another 30, 60, 90. So this reference angle is also 60 degrees. This is also 60. And we have one more 60 in the fourth quadrant. Going back to a 30, 60, 90, one more time. One, two, square root of 3 is always the relationship here. So the x-coordinate of your point will be the cosine of 60. So the cosine of 60 adjacent over hypotenuse will be 1/2. So the x-coordinate for this point is 1/2. The y-coordinate is the sine value of 60. Well, the sine of 60 is the opposite over the hypotenuse in that triangle, so you get square root of 3 over 2. So our y-coordinate is square root of 3 over 2. Now, because this next point is also a 60-degree reference angle, the coordinates will stay exactly the same, but you must have a negative x. In the third quadrant, coming down to the point that's closest to the y-axis, coordinates are the same values. Both of them must be negative. And then in the fourth quadrant, the x is positive and the y is negative. What a lot of students use to help them remember which one's which is that the 30-degree angles are the lines closest to the x, and the 60-degree angles are the lines closest to the y. If you look at this figure, we have taken each quadrant and cut it in half with our lines. So if you think about where this line is, it's halfway through the quadrant, which means that my reference angle must be 45 degrees. In quadrant 2, if we look at where this line is located halfway through the quadrant, then our reference angle must be 45 degrees. Quadrant 3, our reference angle again, 45 degrees. And then over here in quadrant 4, reference angle is 45 degrees. So if we are using 45 as our reference angle, then we need to think about a 45, 45, 90 special right triangle. We know that those have sides of 1, 1, and the hypotenuse square root of 2. And if we do the cosine of 45 degrees and do the adjacent over hypotenuse, we get 1 over square root of 2, which we rationalize to be the square root of 2 over 2. So that means that the x-coordinate for this point is the cosine, which is square root of 2 over 2. If you think about the sine of 45 degrees, opposite over hypotenuse is still 1 over square root of 2, which is rationalized square root of 2 over 2. So the sine value is also square root of 2 over 2. In the second quadrant, your coordinates are the same, but your x value is negative. In the third quadrant, they are both negative. In quadrant 4, x is positive, y is negative. what I have placed here now is a fully labeled unit circle. You must be able to do this for yourself. You don't have to memorize everything. Just memorize the first quadrant and then use symmetry to help you find all of the various point values. Now that we know how the unit circle looks and how all the points need to be labeled, we're going to use that to help us answer some questions. Our first example is that we want to find the sine of 120 degrees. Find 120 degrees on your unit circle. The sine is the y coordinate. So here's 120 degrees on our unit circle. The y coordinate at that point is square root of 3 over 2. So the sine of 120 degrees is the square root of 3 over 2. Exact value means do not put the square root of 3 over 2 in your calculator and get a decimal. Leave it as square root of 3 over 2. For question B, we want to find the cosine of 5 pi over 6. So look on the unit circle for 5 pi over 6. Here it is right here. We want the cosine, which means we want the x coordinate. So the cosine of 5 pi over 6 is negative square root of 3 over 2. For problem C, we want to do the sine of negative 240 degrees. So we want to go into the third quadrant to the line closest to the y-axis to get to negative 240 degrees. So we're starting at 0 and going this way to 240, which is here. We want the sine value of that. The sine is the y coordinate, and that will be positive square root of 3 over 2. On example 13, we are told, suppose that theta is an angle in standard position whose terminal side intersects the unit circle at the point 3/4 square root of 7 over 4. And then we are asked to find exact values of cosine theta, secant theta, and tangent of theta. Let's think about what this means. We are being told that we have a unit circle, so we know that we are in the circle and the radius is 1. Both of the coordinates are positive, so we have landed in the first quadrant somewhere. And so here is our theta. It's the reference angle in there. The coordinates for this point on the unit circle are the 3/4 and square root of 7 over 4. So the only thing about that is just not one of the special angles that we talked about earlier. It's some other random angle in there. The problem is asking us to find cosine, secant, and tangent. So this is just practice on what the definition of those items are in the unit circle. Remember, we defined the cosine of theta to just be the x coordinate in a unit circle. So the cosine of this theta is the x coordinate, 3/4. Done. You don't have to do anything else to it. Secant of theta, secant is always the reciprocal of cosine. So if cosine is 3/4, then secant is 4/3. Tangent's a little bit more difficult because tangent is still defined as y over x. So if we put our y value, which is the square root of 7 over 4, over our x value, which is 3/4, we now have a complex fraction. When you have a fraction divided by a fraction, you take the bottom fraction and flip it over and multiply. Well, the 4's cancel and you are left with the square root of 7 over 3. Our next example needs the unit circle, so I have put the unit circle back in place for us to be able to use it. We are asked to find exact values for the following, and part A says tangent of 5 pi over 4. So first thing we are going to do is find 5 pi over 4, which is here. We want tangent. Tangent is the y over the x. Our y value is negative square root of 2 over 2. The x value is also negative square root of 2 over 2. Anytime you put a number over itself, that equals 1. So the tangent of 5 pi over 4 is 1. On B, we are asked to do the cosecant of 5 pi over 4. So it's the same point, but we want to do the cosecant. The cosecant is the reciprocal of the sine. The sine value is the y-coordinate. Our y-coordinate is square root of 2 over 2. But remember that square root of 2 over 2 came from 1 over square root of 2. So this is the y value, 1 over square root of 2. We want the reciprocal of that for cosecant. So the cosecant will be the square root of 2 over 1. We are in third quadrant, so that is negative. So our answer is negative square root of 2. On problem C, we are asked to find the cosine of 11 pi over 4. 11 pi over 4 is more than 1 revolution, if you think about that. 11 over 4 is the same thing as 2 3/4. So we can think of this as being 2 3/4 times pi. What that means about where we have landed on the unit circle is the 2 pi tells us that we've made 1 full revolution. Now we have to go an additional 3/4 of pi, which puts us over here in the second quadrant. So the point we are going to use is this point. We want the cosine. The cosine is the x-coordinate, and the x-coordinate is negative square root of 2 over 2. For the last example, we want to find the cosecant of negative 330 degrees. So in this case, we want to start at 0 because it's negative. We are going down. And if you think about 330, you go almost all the way. You just don't go those last 30 degrees. So we're ending here. The cosecant is the reciprocal of sine, and the sine is the y-coordinate. So the reciprocal of the y-coordinate at this point would give us 2 over 1, which just equals 2. On example 15, we are told that the theta we want to work with is pi over 4. And then we are asked to find the exact value for each expression. The first example is sine of 2 theta. What you are going to do on these problems is put the value that you were told in where the theta is. So for this expression, you would be doing the sine of 2 times the pi over 4 that we were told theta equals. Well, if you take 2 times pi over 4, you get the sine of 2 pi over 4, but that simplifies to be the sine of pi over 2. So now we want to find out what that equals. Pi over 2 is this point. The sign is the y value. So what does that y value equal? It equals 1. On our second example, we are asked to do the sine of negative theta. If we put our assigned value for theta in, we will be doing the sine of negative pi over 4. What that's asking us to do is start at 0 and go down to pi over 4. So we are using this point. The sine is the y value, so the y value at that point is negative square root of 2 over 2. On example C, we are asked to do sine squared of theta. The first thing you need to recognize about this kind of notation on a trig function, when you see the square on the trig function, what that means is that you are taking that trig function of sine theta and squaring the answer. So now if we put our theta value in, this is saying we need to do the sine of pi over 4 and square the answer. Well, if you go to pi over 4, which is here, and find the sine value, it's the square root of 2 over 2. So we're going to replace the sine of pi over 4 with what it's equal to, square root of 2 over 2, and square it. If you square the top, you get 2. If you square the bottom, you get 4. And then simplify that, you get 1/2. The last part of Mod 3 talks about even functions and odd functions. A function is even if f of negative x is the same thing as doing f of x for all the values of x that you could use in that function. Picture-wise, even functions are symmetric across the y-axis. What that means is if you folded the picture of the function on the y-axis, it would line up and match perfectly. For the definition of odd functions, a function is odd if f of negative x equals negative f of x for all the values of x in its domain. Odd functions are symmetric about the origin. What that means is if you fold it on the y-axis and then fold it on the x-axis, they would look the same. The easier way to remember that is that odd functions look the same if you turn them upside down. What you need to know for trig is that cosine and secant are the only functions that are even. All the other trig functions are odd. On example 16, we are just going to put into play what even versus odd means. We are asked to find the cosine of negative 72 degrees. We are not actually going to do this on our calculator or anything. We just want to understand what this means with this negative sign. If a function is even and you have a negative sign on the angle measure, what that means is that it's the same as the positive angle measure. So we would just say that this equals the same thing as the cosine of positive 72 degrees. On B, what you need to understand when you are doing the cosecant, which is an odd function, and you have a negative angle measure, what that means is that this would be the same as if you did the negative of the cosecant of 5 pi over 8. So if a function is even and you have a negative angle measure, you can just drop it. If the function is odd and you have a negative angle measure, you put the negative sign out front of the function. On our very last example for Mod 3, we are being asked to use a calculator to find these values. The purpose of these questions is for you to recognize that each of these problems is a reciprocal. And so how would you do a reciprocal on your calculator? Cotangent is the reciprocal of tangent. So if you want to do the cotangent of 13 pi over 8 on your calculator, what you have to do is 1 over the tangent of that value, because your calculator does not have cotangent, secant, or cosecant, the reciprocal functions, on it. So you always have to do 1 over the function you do have. So in this case, you would do 1 divided by the tangent of 13 pi over 8. And if you do this on your calculator, you should get negative 0.41 after you round to the 100th, which is the second decimal place. For B, we want to do the secant of negative 270. We're going to use the even-odd idea first and recognize that because secant is even, this is the same as having the secant of positive 270. When it's even, you can just drop the negative sign. Now we want to use the idea that we know that secant is the reciprocal of cosine. So calculator-wise, we would have to do 1 over the cosine of 270. But the cosine of 270 degrees is 0, so you would wind up with 1 over 0. Your calculator will probably say error. What you need to write for this answer when you have a 1 over 0 is undefined. Don't just put error. The formal phrase is undefined. On part C, we want to do the cosecant of negative 240. First, we are going to use the idea that we know that cosecant is odd, so we would have to rewrite this as negative cosecant of 240 degrees. Now we have to use the idea that cosecant is the reciprocal of sine. So we rewrite it again as 1 over negative sine of 240 degrees. Now do that on your calculator and you should get 1.15.